Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is a quick introduction to a technique that I have used in the past to help teams prevent bugs by doing root cause analysis on existing bugs. And this was prompted by a conversation I had a few days ago. We gave an award to a lottery to participants to Agile Coach Camp Romania, and a few of them were awarded participation to the Advanced Scrum Master learning program that we have, and that is self-paced. And in the orientation session, I met with them, and one of the questions and one of the conversations was around bugs. After we did the initial, organizational stuff, we went into, we had a little bit of time left, so we discussed a bit about other topics. And one of them that was very interesting was this, about bugs. And I mentioned that I've been doing this for a while, root cause analysis of bugs. And there was a bit of a misconnect in the sense that they were telling me, okay, we are doing this as well, but what you are describing is a little bit different. And that's what I thought would be very interesting to chat about. So here are a few things I've learned about bugs during my career. One of the things is that bugs are not completely avoidable. I mean, you can reduce the number of bugs a lot, and much more than people expect, much more than developers expect. If your development team is telling you that it's not possible to prevent all the bugs, that's correct, but it's possible to prevent 80 to 90% of them, to the point where you get just a short list of bugs per month, let's say, maybe 2, 3, 10, something like that. Of course, this depends a lot on the size of the project, on the size of the code base, on the complexity, on all these things. But basically, it's possible to reduce the number of bugs. Now, there's a question of economical need here. From an economical perspective, do you need to reduce the number of bugs? And here there are two things that you can take into account. One of them is the cost of fixing the bug. And the cost of fixing a bug is formed of the time spent by people. Somebody gets the report, needs to read it, needs to prioritize it. Maybe you need to estimate it. Maybe you need to plan for it during a sprint or whatever. So there's a whole process there. But even if this process is very short, the next step is for a developer to look at the bug, to analyze it, to figure out where in the code base the problem lies, how to fix it, and so on. And sometimes the solution is quick, but oftentimes what happens is that the solution is complicated, or the source of the bug is not as easy to find. And so they need to go into a debugger, they need to figure out things about how the code works. Often this happens later than the code was developed. I mean, later, much later, let's say. It can happen 3 months later, after any chance of people remembering that part of the code is zero. So basically, developers need to learn or relearn that part of the code in order to figure out what's going on. So that's a challenge, right? Because that's an expensive process. And then they push a fix, it goes to testing, it goes into production, and then hopefully you don't find other bugs, but in reality, often what happens is you find either related bugs or maybe the change that fixes something breaks something else, and that's another issue. So the cost for this can be high. There were some computation at some point that the cost of fixing a bug is 10 times higher than preventing it, but I think this is very contextual. It depends a lot on your process, on how early you get the bug and so on. So it's not very clear whether this is correct or not right now. And I think everybody needs to make their own estimations for this cost. But beyond this, there's an opportunity cost. Developers who work on fixing bugs don't work on adding new features or adding value to your product. And this is a non-zero cost. It's definitely something to take into account. And then there's a potential cost with users who might be less enthusiastic about your product. And this, well, it depends. If they are employees in an organization and they have to use this product, maybe it's not that important to you, although to me it would be, but no, economically speaking, it might not be important. Whereas if they are very flexible, let's say, and they switch easy to another similar application, then there's a cost in users. So, right. And let me clarify that the bugs that we are talking about are not the things like, the button is not colored right or it doesn't align properly in certain configurations or things like that. We are talking about things that are actually breaking the flow of a user, things that stop users from doing something they like. Because we can always improve things like wording or positioning or alignment or design. No, it's a lot of things that you can do. Okay, so with this being said, the cost of fixing a bug is this. And so what is the cost of preventing a bug? That depends a lot on what techniques you use. Some of the techniques you can use are code review or even better pair programming, automated tests, and the one that I'll be focusing on today, which is the root cause analysis of bugs, which is, from my perspective, is the lower cost one. Unit tests are great. I highly encourage you to have a comprehensive test suite that covers your program, your product, and that catches bugs early. And pair programming is also great, or ensemble programming, mob programming, however you call it. These are great because not only they help you remove bugs, but they also prevent other types of issues like perhaps performance problems, security problems, and so on. You may even find better solutions, faster, and so on. But leaving all that aside, of course, there's a cost associated, and the cost is, developers working a little bit different. Maybe they need to be trained into how to write unit tests correctly so that they are not a burden. Maybe they need to be trained on pair programming, on ensemble programming, whatever. And then these activities involve more people. So in terms of pure economical cost, it might sound like it's a high cost. Although, I've argued about this. Programming is knowledge work. I've done a few videos in the past 2 weeks about how programming would look as knowledge work. So you can refer to those for more details. And I think this economic view is wrong because it focuses on the bill metaphor, which is incorrect. We should focus on the knowledge work aspects of software development. But with this being said, let's move into the actual technique. So the second thing that, and I was saying that developers will tell you often that it's not possible to reduce bugs. Yes, it's not possible 100%, but it's possible to reduce them a lot. Second thing we should know about bugs is that, and by the way, this is another technique. If you have less code, it's likely that you'll have fewer bugs. It's difficult to pack a lot of bugs into very small code, which I think should be obvious. Okay, if you really try, I'm sure you can, particularly in languages like C++, but not only. But if you are not trying to introduce bugs, which can be a fun exercise, by the way, just to see what can happen. But in production, I will assume that nobody wants to introduce bugs. You can play with it, but not do this for production reasons. And so in production, if you don't want to introduce bugs, and if you do your best to reduce the number of lines of code, it's likely that you'll have fewer bugs. Okay. And the third one is that, and this is the one we'll be talking more about, is that bugs tend to cluster. And by clustering, we mean that the source for bugs tends to be, if it's in the code, tends to be non-uniformly distributed. It's very unlikely that if you have, let's say you have model view controller, just take a very simple example, that you'll have around 100 bugs in the model, around 100 bugs in the view, around 100 bugs in the controller, around 100 bugs in the other classes surrounding this. Most likely what will happen is that you will have challenges with code in specific areas, and those will create more problems. Okay, and so bugs need to cluster, and I have an intuition that it's probably the things that are not yet mature in your code. And by mature, I mean they were either written very at a close point in time before the bugs appear, or they were written before but not used as much or not changed as much, right? I think about these things like the cooking time for, I like to cook, so I use a cooking metaphor and I say, okay, various ingredients need a certain time to cook. You might want a pizza in 1 minute, but you won't get it. It will be raw, right? You can get a pizza in, I don't know, 15 minutes or so, which is the time for cooking a pizza. And if you want a steak, you know, medium rare steak, certain beef part, it takes a certain while. So, or if you want fish, okay, I love fish. So if you want any of these things, they need to cook for a while. And if you take them earlier from the cooking process, it's likely they will be raw, they will have bacteria, a bunch of other things. So because it's similar with code, weirdly enough, if you use the code before it is fully cooked, let's say, it will have bugs. That's kind of how I think about this. Only, of course, It's more about ideas and how they are represented in code. So the ideas need to get cooked. Take of it as you what you want. Okay, and because of this, a good first thing you can do for preventing bugs is to take the list of your existing bugs from the past, let's say 2 weeks, 3 weeks, a month. Try not to get a very overwhelming number. If you have thousands of bugs, then go on a smaller scale. Pick a week instead of a month or something like that. The idea is to analyze like few tens, maybe 200 bugs, and look at some of those. Actually do it with your team. So get your team together, look at some of those and start asking, okay, so why did this bug happen? Well, somebody made the change somewhere, whatever. Okay. What caused this to be a bug? Well, because the change was wrong, or they missed something, or okay, and so on. You keep asking why, and until you get to a cause, and then you ask the next question, which is something the group that I was discussing this with didn't expect. The question is, what can we do differently so that similar bugs don't happen again? Okay, and so what you do is you look at what things you could change in your code, so maybe refactor a part of the code, in your process, or in your tools. And what I mean by this is, maybe there's a very complicated function and you need to change it, and programmers don't fully understand it and they make a few mistakes. And because of that, you get bugs. Okay, what can we do there? We could refactor that function in a way that is easier to understand, and maybe keep some of the things more protected from the newer changes, because we separate them in smaller functions. And then whenever you need to make a similar change, maybe you add a new thing, you add a new function, or and reuse some of the existing ones. Or maybe you write some unit tests, but only on those specific areas, so that if somebody changes that, the unit tests will tell you if you make a change that is not correct. And another common situation is that programmers make a mistake that's not visible in the development process. I worked with a team once that was doing smart meters, and we looked into their bugs. We did this root cause analysis, and it turns out that the problem was they were allocating more resources than the device supported. This was an embedded kind of thing. So because of that, I think it was the number of threads they were starting or the heap memory they were allocating. I don't remember exactly. It was a very long time ago. But let's say the number of threads they were starting. So because of device limitation, they could only start a limited number of threads, and they kept starting more threads than that limited number. So what can you do in this situation where you can change your design to prevent this from happening? You can have a thread pool, and all the threads ask from the thread pool instead of, or simply a counter, right? You might not even go as far as a thread pool. You might just have a counter. Each thread, new thread started, checks the counter if there are more. If it tries to start more threads, then it cannot, and maybe gives a long message or something like that. And at least that protects against a specific type of error, right? Another possibility is that people are making, programmers are making repeated mistakes of a specific kind. So it's not necessarily that an area of code has a problem. Maybe they just introduced like a newer version of a library or a newer coding pattern that they need to use, and they consistently make mistakes in using that. In that case, what can you do? Where code review, you should have a checklist for code reviews, by the way, and you could add to your code review checklist, now check for these items. Or you could go even further and do a new rule in a static code analysis tool. Maybe you write your custom rule, or all these static code analysis tools allow you to write your own rules. Or maybe you write your own rule that covers this specific situation that you are seeing. Or maybe there's an existing rule that kind of matches, but it's not enabled. So the important thing is to look at it from purely a process perspective. And this is something that's reminiscent of my work with usable software design, where we look at software design as being something that is used by programmers, and then apply the criteria for usability to software design. And one of the criteria for usability is called preventing errors, basically. Think about it this way. What you're doing for a user interface for a user is to organize the interface in such a way so that they can do what they want to do, but also that you prevent some errors that they might do. Maybe you ask them, these are the common mechanics, right? When people want to delete something, you validate with them. Do you really want to delete this? If people want to, I don't know, delete their account or something like this, there's a red button. It says this is dangerous, things like that. It tells you what it means, whatever. We need to do similar things, but it's not exactly the same implementation for software design. So what we need to do is to look at the design as something that can either help or prevent bugs. Because bugs are mistakes made by somebody. If the mistake was made from requirements to development, then fine, okay. Maybe we didn't have the right requirements, maybe we didn't understand requirements, we need to work earlier on in the process. But if the mistake was actually in the implementation, which is when you get more technical errors, then the question is, how can we adapt the design so that developers don't make this mistake again? Because they are the users of software design. And these are some of the things you can do. You could also, there are some more advanced techniques here, like marking specific areas of code, correct at compilation time, which is a very advanced technique and typically leads to It uses very strong typing, but typically leads to a very code that's very difficult to understand. So to me, that's extreme. It's an interesting approach. I don't see it very valuable, but you can try it. Why not? And I think we discussed about this in a series on strong typing in previous videos. But the general idea is to think how you can protect, how you can change the design. And that involves the structure of the code plus the process that you use to validate the code, so that errors like that don't repeat. Okay, so don't blame programmers because they made those errors. That's not the right mindset for this. The mindset you need to go with is, okay, programmers kind of walked the path. What can we do to prevent similar errors from happening? And never blame anyone. No, it's not the programmer's fault, it's the system's fault. Something is confusing, something is unclear, something is, not adapted enough to the needs of the programmers. Another example would be if you need a new kind of coding pattern to use. Maybe you introduce, I don't know, some asynchronous call mechanisms, some concurrency, some parallelism, whatever. And you see programmers making the same mistakes. Maybe what you need is a little bit of code that implements the infrastructure, and then programmers can just call that thing. And for 80% of the cases, it just works. And for the other 20%, you have more checks, more conversations, or you introduce different patterns or whatever. Or you do more training. Okay, so that's the general perspective. And this is what I wanted to talk about today, which is preventing bugs through root cause analysis. This is the cheapest thing you could do because it's like a surgical intervention on your code and on your process in order to avoid future bugs. And this is irrespective of unit tests, of the tools you use and all that. You can apply generally in any context. And as long as you go far enough with the questions and with the right mindset, I'm sure you can reduce a lot of bugs like that. There are very few things I'm sure about in software development. This is one I am sure about. I've seen it working again and again. I think it just makes sense. It clicks. There may be contexts where, and I'm sure you will tell me if there are contexts where it doesn't work, but generally speaking, it's an easy way to start dealing with bugs. And if you have, let's say, thousands of bugs, if doing this repeatedly cuts down, let's say, tens or hundreds of bugs from your future, imagine the time you are freeing for your developers to do something else, or maybe improve some more. It's something that seems to add up in terms of speed, because they will have more time to focus on either on adding features or on repeating the same process to remove the other bugs. Okay, so that's it from me today. What do you think about all this? Does it make sense? Is it something that you have tried? Is it something that you would try? Let me know in the comments. We love comments and really love having this community Thank you so much for watching these videos, for listening to them, for interacting between yourselves and with me. It's really great to see this. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.